Good morning, everybody. February 21, 2024, Nefio SIG Automation Meeting. So today I put on the agenda, I'll be taking up the whole time, a kind of deep dive into a POC I've been working on. I presented it in the summit, the R2 Developer Summit, but it went by very quickly and it kind of was a little bit of a distraction, I've been told, because it seemed to try to suggest that we might move things in a different direction. But maybe it's become more relevant now where we have a situation with Porch where we don't really know where the future is. I think some of us have been looking at scalability issues and decoupling issues, connecting to other orchestration systems. So I thought to do a revisit here, but also in SIG Automation, where we really look at the code and I try to explain my proposal here. So let me share my screen. I will share the entire screen. So this is the TKO experiment. And in the README here, I'll go over it very briefly just to give you an idea of what I'm trying to do here. So it is a complete rewrite of the Nefio core. And the idea of doing that was exactly to experiment with different approaches to doing things. It does a whole bunch of other stuff. I'll delve into a little bit, but it's also a way to play with a different way to do specialization. So Wim talked about that too a little bit. And yeah, the idea here is to not use a pipeline, but to use a kind of different approach to what I call preparation instead of specialization. Also, a different approach to instantiation, right? The idea, a meta scheduling idea that I introduced before. A different approach to topologies. Topologies here are part of the preparation approach. So it's just a regular template that gets, during preparation, exploded into the subcomponents of the topology, including creating sub-deployments for every site that you're placing templates into. And I'll show that it also works as Tosca with the front end. And also a different approach to validation. There's a plugin-based approach to validation and an idea of partial validation versus complete validation. It includes an SDK for Python plugins, metadata support, which ends up very important for the configuration as data approach. There is built-in support for Helm, and also that's part of the kind of meta scheduling paradigm. There's a web UI, and there's a terminal UI, which is pretty fun. So some deeper things, maybe less immediately interesting. This is written IPv6 first. Dual stack is actually far more complex. Diving deep into this, I found out that it's definitely not trivial to support IPv6 and dual stack, and there are some tricks to do this properly, so I can go into. I did a presentation for SIG1, one of the work groups, regarding a general component proposal, and this fits into this exactly. This is basically an implementation of that. Here I'll show you the architecture. And by the way, this graph was done with Mermaid in GitHub, so that's kind of cool. It's a little bit buggy, but it's a very nice way to include diagrams in Markdown and make them easily editable by people, right? So what are our components? There are three controllers in this POC. One is the API server up here. It is works against any backend. I'll show you how the backends plug in. And all it does is really export that backend with gRPC. And I'll explain why gRPC in a bit. So that is kind of a very one-trick pony component. All it does is take a backend and expose it with the gRPC interface. It also exposes it.
Quick question: This is not the Kubernetes API server, right? So that is just gRPC API server, correct?
Correct. Although it does run in Kubernetes, and I'll get to that as well.
Yeah, but it's not using the Kubernetes API ecosystem.
It does not, but the meta scheduler can. Absolutely does.
Yeah, okay,
so
but it's just a clarification. So it's basically an API server with gRPC endpoints. Okay, yeah, that's my
right. But I'll remind everybody that Porch kind of does the same thing too, right? The the package resources are stored in Git, not in etcd, right? So it uses an aggregated API to present it. Yeah.
But the difference is that you still use regular Kubernetes controllers that can access it, whereas here you have to write a translation layer, right?
We'll get to that. Yes, and that is a purposeful part of this design, using gRPC and not etcd, right? So I'll get into that, right? So the other two controllers are the preparer. So it is in charge of, so it again talks to the back end. So it finds out, what all the deployments, templates are, etc. And the third component is the meta scheduler, right? So the job of the preparer is to go over all deployments that haven't been prepared yet and prepare them. So there's this deployment preparation area here, right? And the way it works, when you create, when you want to create a deployment, you start with a template, although you don't have to. You can start with nothing and you don't have to use a template. You can just merge in a bunch of resources. I'm going to be talking a lot about merging. So workload templates are the simplest. They come with, a bunch of KRM, right? All of these are packages, KRM packages. And they start being unprepared. And the preparer is in charge of finding whatever is unprepared in that package, preparing it, and making it prepared, right? And once it's prepared, the meta scheduler looks through all the deployments and looks for things that are prepared and approved, by the way. I'll talk about approval. It makes sure to schedule these in the right place, right? So most of its job is to get it to the workload cluster. But it could also, if you're working in a Kubernetes management cluster, it could schedule things locally, right? If you need to work, say, with an infrastructure manager, that is a standard controller. So this is where, Wim, this kind of half answers your question in terms of working with the Kubernetes API, right? If you're working in a management cluster, you can definitely schedule things there. The question that I keep asking is the scalability concerns, right? When you're dealing with millions of sites or hundreds of thousands of sites and millions of workloads, and you're storing them all on etcd in the management cluster, you have to ask, what are the limits, right? And we can talk about that a little bit later.
Yeah, but even my point is that even today we don't do that, right?
Right. Even today we don't do that, although there has been a proposal to do that and move from an aggregated API to true CRDs. And I'm concerned.
Okay, but that's debatable. I agree that that's not the right way forward, but here you are.
Okay. Well, you know what? Let me go over this, and then we can debate pros and cons, maybe. There are site templates too, which can be used also, can be prepared kind of in the same way, and they can include all this stuff about infrastructure management of a site, right? And these are used, site templates are used when you provision new sites. Part of my assumption here is that a lot of times you'll be using an existing site catalog, and it's just exists in the API server. So the sites might already exist and in an inventory, and a template is only used when you want to provision really a new site. So the site inventory might include existing sites. Topology templates are simply different kinds of KRM that refer to other templates, and unprepared topologies become a whole bunch of maybe new deployments on new sites. And they can be nested in any level. So a topology could actually include subtopologies, and they could get further exploded, right? So you might have a topology called an ORAN CU, and then you might have a higher level topology that involves multiple CUs and DUs over many sites, right? And again, I keep thinking here in terms of millions of rows, millions of entities, and you can do that here with metadata selection. So I'll show you how this works. So this is the basic architecture. And yeah, I mentioned here the plugins too that could be written in Python for every step of the way. So you can create your own preparation plugins, validator plugins, and scheduling plugins. Those are the three kinds of plugins. This is the backend interface and kind of like the core of everything. It's pretty straightforward, and it's essentially declarative, right? It's You can set a template, get a template, delete a template, list a template. Set a site, get a site, delete a site, list a site. Deployments are a little bit more complex. There's you don't just set a deployment because you want to modify it, and you want to make sure that it's an atomic modification if a lot of the controllers are trying to change it at the same time. So you basically start a deployment modification, you get a special token, and you can end that deployment modification when you're done. And there is a timeout, right? If you don't make the change in time, then your modification will be released and other people can modify it. So a deployment will be locked while you do that modification that you need, and you can cancel at the end. And then you can also configure plugins in the same way. Implementing this backend is the memory backend. This is the first one I created just to ensure correctness. And it just stores everything in Go maps, hash maps, and other things. So it's a very straightforward thing. This was really just for testing and to verify correctness and for mocking. So this is a pretty straightforward backend. Here I'm creating a deployment. So I need to return some sort of, modify deployment here. Start deployment modification. So you get a token, you get a timestamp when you started it, so it can check if it was timed out, right, when you actually do the modification. This was pretty straightforward. There's a Postgres backend. And I'll be honest, this was where I did most of the work on this project. A lot of the stuff is pretty straightforward, but SQL statements and mapping them, this required a lot of fine tuning. Here are all the SQL statements written by hand, creating the tables, doing the selections. Everything is basically a row, every entity with all the resources stored there. They can be stored either in YAML or in CBOR, which is a binary way of kind of storing the same structures to be a little faster and more efficient. Use YAML if you prefer more debuggability, that you can look into the database directly and see what's going on. The reason I chose Postgres too is Spanner, which is Google's planetary scale database, supports the Postgres language, SQL language variant, dialect. So it would work there. However, I don't have a running Spanner example right now because I did it internally in Google. Spanner is not free. So if I want to do something that people can use here with Spanner, I would have to have some sort of paid account. If there's interest, I can look in maybe getting something like that for Nefio for experimentation. But honestly, there's not too much to do there. You can just deploy Postgres and it'll work, right? We definitely don't need planetary scalability, but Postgres is designed for this. I mean, you can have a single Postgres cluster and easily do hundreds of millions of rows, right? This is what databases do very, very well. The big advantage of using a SQL database is the queries, right? If you're querying millions of rows, and a database can actually absolutely do that. So this leads me to why I kind of picked a gRPC. gRPC is not only very widely supported. It's supported by Envoy, service meshes. You can do a lot of things with the gRPC API, load balancing, but it's also a streaming API. That's very important because when you return, if you're doing a list deployments, and the deployments are, let me show you exactly how it works in SQL. So list deployments here starts building the SQL with all the selections that you want to do. Let's say you want to select on metadata. You might get millions of results back, right? If the preparation is going, the preparer is going right now and looking for all unprepared deployments, there might be millions, right? How do you return results like that? You cannot do that in JSON, right? But with gRPC, you can absolutely do that. So it's a streaming API. So the backend is streaming and the API is streaming. So here, I kind of handle streaming. I send it to a stream one at a time. So it can easily handle millions that way, right? You just keep sending more and more over the stream. So that's the backend. I'll show you the, so the API server adds just a gRPC server over everything. And it's pretty straightforward. It's just kind of boilerplate code that validates, takes the gRPC structures and calls the backend with them, and does some error handling and things like that. So that's pretty straightforward. And I can show you here how it does streaming. So we get the results from list deployment, we iterate them, and then, send them over gRPC. And the gRPC client, the same way. So there's this source code here for a client that just makes it easy to use gRPC. Just makes it a little nicer. So here, if we do a list deployment, right, we get the client, we do a gRPC call, list deployments, and then again, we stream it, stream the results. So you're always working with streaming, right? So you're kind of iterating one at a time. There is actually also an HTTP server, and I mentioned this exists only for the web API. You can actually use gRPC inside a browser, but it's very limited because of how the browser handles HTTP connections. So you cannot do streaming, which is the whole reason I wanted to do this. So instead, I created a very, very simple HTTP server here that just returns results without streaming. So this will be limited in some way with paging or something like that, because browsers can't handle it that way. So that's all the API server does. Actually, it does one more thing: validation. So you can create this validating backend wrapper around any backend, and all it does, it calls the underlying wrapped backend, but adds validation to everything. So what this does is make sure that you never get invalid data into the backend, right? You validate it before you actually set it to the backend. So if there's a validation error here, you'll get an error. So it doesn't even get to the backend, right? And validation works in two ways. You see this true here? So you validate the resources, but you also specify whether you want complete validation or partial validation. Complete validation is what you absolutely need for a fully prepared prepared deployment. But until it's fully prepared, you still want validation, but it's what I call partial validation, because a template does not have to be fully validated, right? It might be missing data that it needs to, to get fully validated, right? And part of the preparation is creating that data. So in partial validation mode, we don't check, we allow for missing properties, right? But properties that do exist, we want to make sure that they're the correct values, right? So when you create a validation plugin, you can actually support those two modes, right? Support partial versus full. That way you can make sure that if you do send templates to the backend, you make sure that they're at least partially validated, so you don't get a bad template. Of course, another way to do this is put placeholder properties, or defaults, sensible defaults, but to make it complete. But I've always disliked that, because defaults are dangerous. If users forget to update the defaults, then you might not have what you need. I think it's always better to get an error, hey, you didn't specify this property, instead of having some unfavorable default behavior. So that is the API server. It does validation and handles the backend and exports it over gRPC. And then we have the preparer that, the way it works, as I said, the basic controller loop here is it prepares all the deployments. So it just calls the client, lists all deployments where prepared is false, and goes one by one and prepares it. And I'm going to go into preparation in more depth in a bit. And then the meta scheduling works kind of the same way. It goes through all the sites and includes all the deployments associated with the site that have been prepared and approved, right? It has to be prepared and approved for it to be included. And this is kind of interesting. The scheduling works by, the unit of scheduling here is the site plus its deployments. And the specific reason to do that is that deployments can include infrastructure requirements, right? So you might have the site data itself, but every deployment might have a specific requirement, right? So the scheduler would know how to incorporate those infrastructure requirements. It can give an error, say that you did not, we have conflicting requirements, or maybe you have a certain workload, that a deployment that needs I don't know, certain kind of NUMA pages. So it would be able to schedule some nodes in the cluster with those NUMA pages and associate that there, right? So the scheduler can do everything it needs to do to make sure that it is scheduled properly. Included right now is a very simple scheduler plugin. It'll be here under examples. So we have a schedule kind, that just schedules a kind cluster. So it can provision new clusters and send the deployments. And you can see here, all it really does is call kubectl to apply the resources. And with Helm charts, it does something interesting too. So it can just calls the Helm command line to install the chart, right, according to its prepared values. So this is a very straightforward scheduler. Really, this is the whole code for scheduling, with some APIs that are being called. But a config sync version of this would just take that and commit it to a repository for the site, right? So you can create schedules in any way you want. A Red Hat scheduler would work, of course, probably with ACM or some other system. You can create a scheduler for Flux, for Argo, or whatever it is, however way you want to connect. And as I mentioned, Wim, the scheduler here too could actually, if it's running in a management cluster, it can also schedule some things locally in the management cluster, right? If you have infrastructure requirements, for example, and you have an infrastructure operator, management operator running in the management cluster, you can put those there, right, in the management cluster for it to pick up and reconcile, right? So freedom to do what you need to do there. Yeah.
My question is, how do you resolve the dependencies between the deployments?
Sorry, I couldn't hear you.
How do you resolve the dependencies between the deployments?
Oh, that's part of preparation. So we'll dive deeper into that. Okay, let's see it running a bit. Those are the three main components. So very easy to build. I'm running this locally right now. So again, you know what? Let's let it run first, and I'll show you some more stuff. So it's actually building the three controllers here in the command line tool. That's just the client, registering a bunch of templates in site, and let's run the TUI dashboard. I love TUIs. They're really fun. Right now, we're seeing all the deployments locally here. The nice advantage of a TUI, you can access from any terminal. So this is a pretty rich thing. This supports, so we see all the deployments here, they were created. We saw the topologies. There's a CU and DU that have been exploded into child deployments. So we have SMFs and UPFs here. And slowly they're being prepared true. Some of them have been auto-approved. That's the default. Some of them stay on approved false because I specify that I want manual approval for them. So these are all the SMFs. So I can approve them manually if I want. Some of the sites here you see have already been part of the catalog. Some of them have been newly provisioned, so they got an ID. And by the way, this TUI works with a mouse, so that's pretty cool. So any of these I can double click and get the full package. I can see all my sites here. So per site, I can see how many deployments I have. And here are the templates that I have registered. Here are the plugins. So I have 2 preparation plugins, scheduling plugins, validation plugins. Every plugin has an executor. So these just executed Python commands, but you can also include kept functions. So here I'm actually using the namespace, the set namespace kept function. There's also, I'll show you, the web UI. So it's the same kind of thing as the TUI, but I think much richer. And as I said, this uses kind of the HTTP export. So here we have room for the metadata as well. So you can see the metadata associated with everything. Metadata is just key value pairs. And this is very powerful because I can do selections based on metadata. So I can do operations, for example, on all SMFs in India. Right? And again, that could be hundreds of thousands of rows, but that's handled with a SQL query. So it just streams to you. So I think alleviates many scalability concerns, right? So I can look at all of these here. So yeah, both of these UIs are read-only. Here you can see the plugins. And you can see per plugin, you can see more here. So you can see which command it's actually running, a Python script. And they get triggers as well. I'll talk about what triggers are. These are GVKs. So it's a list of GVKs that will trigger this plugin. You can also specify no trigger, which means that the plugin will always work. But this is simply an optimization to make sure that you don't run every single plugin you have every time, but you can kind of pick and choose when they run. Basically, if a plugin doesn't find the resources that it needs to work with, it should be a no operation. But yeah, this might have been over optimization on my end. Here are all the templates I have registers, and templates have metadata too. When you create a deployment from a template, it will inherit all the metadata that's there, and you can add its own. So here we have templates for network functions as well as sites. You'll notice that every entity here has a name, and the name is also kind of a metadata because you can actually do searches by the name using wildcards. And that, again, works against the back end. So it's part of the SQL query with regular expressions. So for example, let's say I want to look at all the templates that are network functions. So I can do TKO, template list, metadata. Let me remember what it is. So it's network function.type. Oops. Oh, did I write it? Oops, too many windows. All right, not sure why that didn't work, sorry. Are all the templates here? Oh, well, I broke something. But I can also do it by ID, so I can do nf/. Okay, that at least works. So here I get, yeah, all the templates that start with network functions. So the name itself can be a way to also filter things. So in addition to the metadata, which I think is useful. So you can create hierarchical naming structures, etc. Let's dive more into preparation, because I think that's where some interesting things happen. So let's look at some of the example templates. So we'll look at UPF, a simple workload, right? So we have just a deployment. Here I'm actually deploying Nginx, never mind. So straightforward KRM. Here, metadata. So metadata resources, I can structure them as I want. And these are automatically bubbled up into the backend. So it'll look for all these metadata.nefio.org resources, and all these things just became those attributes that we saw here. So these are exactly from there. It just bubbled them up to the backend. And why is it doing that? Because these actually become indexed values in the database, so you can actually do that kind of scalable queries using that. So you define them in KRM, that doesn't change, but they bubble up, right? Here I'm specifying an input for the plugin, right? And this is where it differs from the kind of kept pipeline going on right now, right? I specify everything in KRM with its own resource rather than a pipeline with inputs. So in my opinion, this is more actually Kubernetes-like, right? And you see here's workload.plugin.nefio.org. If we go back to the, so we go back to the plugin, this is exactly the trigger. Oops. This is this trigger here. So I've registered that plugin for that JVK, so it knows that it needs to prepare that, right? And it will just run the kept function, sorry, on that. So yeah, so I did need to specify the kept function will error out if you don't put a name, so I didn't need to specify something there, underscore. Okay, so that's how this will be prepared. The SMF, I try to make a little bit more complicated in that its workload is actually a Helm chart. And we discussed yesterday in the SDK meeting, there's a little kind of expression language here that makes it a little bit easier. Instead of writing a full preparation plugin, if all I need to do is pull this name after the kept function prepared this, then I can give a little expression language here to pull it directly. And this is handled during scheduling. So these are the input parameters for this deploying the Helm chart. I'm specifying also an infrastructure requirement here that will be handled again by the schedule. So let's say I need SRIOV for this. And I mentioned that all the SMFs here, I disabled the auto approval. And the way I did that is actually merging in this deployment resource that every deployment gets. So if a template does not have this deployment resource, it'll be merged in. And this is kind of a way to keep the status of the entire deployment. I'll show you how it looks after it's been prepared. So if I look, say, at this SMF deployment here, here's this deployment thing, and you can see it's already been updated. It has the site ID, the template ID I was based on, if I was based on a template, and if I am associated with a site. And here you can see all these other things that were added. It's been prepared. So that annotation tells me that it's been prepared. And again, this bubbles back up into index on the database. So, we can actually search by preparation according to a simple column in the database. Yeah, and here I merged in the approve manual to make sure that it won't auto approve by default. So that's kind of like, it's a little bit like the kept file in that, every package has a single kept file in it optionally. So the same thing here, every deployment has a single deployment file, deployment resource that kind of gives you information about the entire deployment. And here it's already fully prepared, so you can see all the data has gone in. All this stuff is things that the kept function adds. It likes to it likes to add a lot of annotations. So that's a Helm chart based deployment. Sites, if I want to deploy a new site, so here's a lab site. This is a GDC site. I didn't put any spec in it. But if I want to deploy a new lab site, which is based on kind, here I'm giving metadata for it. I want to specify provider, kind, region, local. And I just associate, I just put the kind KRM exactly here. The nice thing is that kind already uses its own KRM of this type. So it's just here as part of the template. And the meta scheduler has a plugin, as I showed you for scheduling kind. So it'll just read this and do whatever it needs to do with this. And of course, this can be prepared as well. So there can be a preparation plugin that changes this data in whatever way it needs before preparation. Topologies are interesting too. So here is a topology resource. And the way it works, it takes templates, a list of templates, and associates them with sites. Here's a simple UPF to one site. The SMF here is to what looks like 4 sites, but actually, I'll show you something. This last one is not a single site, but rather a selection of sites. There's merge too. I'll explain in a second. That's very important. And all right, so each one of these is actually the name of a KRM resource. So here are the sites. Here's Edge 1. Here I wanted to show that I can give it a direct site ID. I know exactly where I want to deploy it in the system. Edge 2 is a provision site. So I say provision if not found. If you don't find a site of this name, provision a new one. And when you provision, you can actually merge in some more resources. Again, I'll explain that in a second. Here's the kind cluster that I want to merge in for the provision if I want to kind of change the defaults. This is metadata for it. So Edge 3, again, provision if not true, but provision from this template and merge these things into the template. So here I want a GDCE site. This is sites. So remember I said that the last placement here, Bangalore, is actually a collection of site. So it's not of type site. All of these were of kind site. This is of kind sites. And the difference is that I can select by metadata and other parameters too. I'm saying here that I want every site that is in Bangalore of type GDC. This could be millions, right? This could be many, many sites. So again, the streaming API makes sure that even if I have very, very large results, they would work here. So this single placement could actually deploy to not 4 sites, but 1 million sites. And this would work, again, with the streaming. So this will get exploded, right, into all those child deployments that we see here. Oops. Right, so you can see here the parent deployment ID for the CU ends here in DB. So we can see all of the, here, all of these. Here's the India Bangalore sites, all the sites that it found that were selected, including the newly provisioned ones. Support for Tosca. So for the ORAN DU, I decided to handle it in Tosca. So the KRM is very straightforward. There's a Tosca kind that you just give it a URL to a Tosca CSAR file. And I know not everybody is fluent in Tosca here, so I won't say too much about it. But here it is in Tosca. So it's just the same placement that we saw, but expressed in Tosca. So Tosca is just more elegant for doing these things. So here again, I'm defining a UPF. I'm giving the type. That would be a template. And I'm specifying the properties for it. Here's the SMF. And I require it to have sites. So here's a single site. And here's a sites that I can filter with, select with metadata. So there's a Tosca version of this, right? Merging. Merging is a very important part of how this works and how you actually change templates. So whatever you get from templates will be prepared with the plugins. But so for example, this placement topology has a built-in plugin that will automatically explode all this, right? But then per template, you can actually specify references, object reference that you want to merge in. This is how you inject your own special configuration into the template, right? So for example, if I want this SMF template to have a different namespace, I inject in a namespace here, right? And give it the name that I want to put there. So it will be merged into the template. And the way merging works is that if I'm specifying a new resource, it'll be appended. But if the resource already exists, it will merge the properties into it, right? And that lets me update the template in any way I want, right? This is how I handle inputs, right? And also how I modify that template according to a specific output that I want. So I can merge anything, infrastructure requirements, changes of namespace, and per network function implementation, right? So here I'm merging. I want to change something in the Free5GC SMF, so I can give it a change the spec here, and it'll be merged in. This is very powerful. So here in the spec, I can specify the same template multiple times with just different merges, right? If I have different configurations for how I place. I think it's a pretty simple metaphor for really handling all our kind of data inputs and modifications together. There's some interesting caveats to this. So you'll notice here that I'm merging this in, right? And here's what I'm merging in. I added an annotation saying, prepare, postpone. The reason I needed this is the problem is, even though I'm merging this in, this resource exists here in this topology, but I don't want it to be prepared in the topology. I want it to be prepared only after I create the child deployment. So that's what the postpone annotation means. And also I can rename it after the merge, because I'm calling it SMF1 here, but maybe in the template it's called SMF and I want to override that, so I can rename that too. So all these annotations that can help you deal with that. And just for the record, this is all documented. On the website, there is a reference guide that I talk about all the different kinds and all the annotations that are supported if you want to disable auto approval, etc. Oh, by the way, as long as we have it running, maybe we can approve these. So you can approve So the CLI, oh, deployment approved. And you can filter this. I can approve, like, say, only SMFs. So I don't know. Metadata. Okay, that didn't work. Maybe it'll work this time. Network function type equals SMF. Oh, according to. Oh, well. Not everything works perfectly. Let's just approve all of them. So it'll go into everything that's not been approved and approve it. And yeah, all of these are now approved, including, we can check in the this dashboard. It's all approved. Okay, so now they would actually be scheduled. So that's how preparation works. And all of these preparations are done with that atomic change. So even if you have many prepare controllers working at the same time, right? Because in a real production environment, you won't just want one prepare working on millions of rows. They'll need to kind of shard the work between them. So that can be handled. And if two work on the same deployment on the same time, you can be guaranteed an atomic update. Something that's been very challenging for us with Nephio right now in Porch, and because there's no way to lock Git repositories, right? So that's kind of difficult. And maybe one more point about the backend. So here I implemented it, as I said, with SQL. But the point is that you can create your own backend implementations that integrate with East-West systems, right? So if you already have a site inventory, you can implement a backend that just implements these functions, but just needs to make sure that whatever format your site inventory uses, you have to express it in KRM so that Nephio would be able to use it, right? So that's the only thing. So you can translate it back and forth to KRM with that. And you can create, if you really want to use GitOps, there's no reason why you can't implement, say, templates over Git repositories, right? So you can create a backend that does all of this in GitOps if you really want, and kind of mimic Nephio Porch's current behavior, right? Although I would argue that if you really want to store your templates in Git, nobody's stopping you from doing that, but you can just register them back in a database, right? And that way you don't have issues with tagging and versions and all that, right? So there's still an advantage to storing them here, because you can have a backend. For example, when you create a deployment for a certain template, it can just fetch it from the internal database instead of like calling this other API to get it from Git. So yeah, you can mix and match. That's my point. And you can even multiplex, right? You can have a backend implementation that uses both an external repository and an internal PostgreSQL database for newly provisioned sites or something like that, right? So you can integrate multiple data backends together here under a unified API. So again, with preparation, what's kind of special here is that, everything, the way the preparation loop works, and this is documented as well. So I go here in some detail over the loop, right? It goes over everything that's not prepared, every deployment that's not fully prepared, and it starts trying to prepare resources that are marked for preparation, right? And it will call the plugin if there's something triggered in that for that. And every plugin, I'll show you how a preparation plugin would work. So here we have plugins. So let's say to prepare for free 5GC, so I'm checking that the target resource for the preparation is indeed the SMF. I'm making sure it's my SMF one, that I haven't been triggered by something else. And then I can basically change the, do whatever changes I want to the entire topology, the entire package. And when I'm done, I set prepared true. And what that does, is, so here let's pick one of the SMFs. That's metadata, Helm chart, infra. Here's an infra requirement. So here, yeah, here's the thing. So what it did was set prepared true, and that marks this resource as prepared. And basically, I'll show you the code for the preparation loop. So we're preparing a deployment, it basically goes through all the resources. And when it's done, it checks if the deployment is fully prepared. And if it is, it sets that prepared annotation, and we're done with preparing that. And as I showed you, if we have auto approval on, it will also set the approved annotation, right? So if it's manual, I'm not going to auto approve it. So preparation, scheduling. What else did I want to talk about? Any questions so far? Oh, I did want to show it running on Kubernetes, right? Sorry, that's the big one that I wanted to show. That's a big point of contention. So, I mentioned before, and I think some people got a bit upset with it, that I'm questioning the idea if we actually need management clusters, right? And if it's a good idea. And the pros of management cluster are obvious, right? We have already a ready-made control plane with Kubernetes, and we can run everything there. And then we can add other controllers there and deploy other systems that work together with Nephew, right? So I'm not saying you shouldn't do that, right? And I'm fully supporting it here. As Wim pointed out, yeah, I'm not using the API here as gRPC, but it's on purpose, right? Because etcd is absolutely, I think, unsuitable for dealing with large amounts of orchestration data, right? There's no streaming protocol. etcd does not do any real indexing other than GVK. So if you want to query, for example, all the deployments that haven't been prepared, you're going to have to walk through all the deployments that you have as CRs in the management cluster if you're using etcd. There might be a million of them. You're going to have to go through all of them and check if they're prepared or not. There's no ways.
That's correct. I think, Tal, what you're saying.
Yeah. So
there is
I will say
there is an indexer. There's an indexer that takes care of this.
Yeah, but that's done in code. It's not on the etcd backend. And anyway, you can create your own indexes and things like that.
You can. You can.
Okay. All right. Yeah. Okay.
But I think what I think we have to clarify, right, is you're basically arguing against etcd, right? There is a second. I think we are seeing here. There is basically three ways, in my view, to use the API system. You're highlighting two of them. There is a third, okay? Which is basically what you are doing is you're creating a new API machinery, right? Behind another storage, right? There is a second, there is the current approach, where we use etcd as a backend using the Kubernetes API machinery. There is a third one, which is using the Kubernetes API machinery with another storage.
Yeah, an aggregated API, right.
Yes, and that gives, takes care of, or can take care of a number of scale. What I see as a big advance of that is that you, as a consumer, you have no difference. Whereas here, you have to go to a completely new ecosystem.
So I'm not precluding creating an aggregated API too. I actually started experimenting with that. Yeah, you can absolutely do that if you want everything represented with etcd, right? What etcd doesn't let you to do is
no. So basically,
sorry, not etcd. Sorry, you're right.
You're
I misspoke.
yourself
with the Kubernetes API server. Yeah, you can absolutely do that, right? I didn't do that, but you can. Yeah. I think gRPC has various improvements, right? I think it supports, streaming, right? Which, the Kubernetes API does not, because it's meant to be RESTful. Internally, it is a RESTful API. It doesn't support locking, right? REST doesn't do, if you're getting a deployment and want to lock it until you change it, then, the Kubernetes API does not
depends again on the storage, Tal, right? So that depends on the storage how you consume it, right? So that's not necessarily tied to, so that's depending on implementation. So for example, okay, we will release soon something that does exactly that using the full API machinery and locks until the full operation is done.
Yeah,
You can
there
do
are
that
ways to do
without
it declaratively, right? You
without
can create a
changing the whole
resource.
paradigm, is what I'm trying to say.
Yeah. So look, the native API here is actually not even, so you can see under API, I have gRPC server and HTTP server. There could be a Kubernetes server too that does it with an aggregated API. The real point is implementing the backend, right? And the main reason here, etcd, there are even talks in Kubernetes about in the future maybe allowing you to replace etcd with something else, because these use cases are becoming more common, right? But another point of decoupling is not just to use Postgres, but to actually integrate east-west with an existing site inventory or site inventory or a template repository. If an organization already has these other systems running and you want to integrate them, you don't want to duplicate them into etcd or whatever it is. You want to integrate them directly, right? You don't want multiple sources of truth. So that's part of the point here, that you can create a backend here that gets those sites directly. And if you handle this backend, and let's say I add a Kubernetes server here, then it will automatically expose those right into a Kubernetes cluster.
Yeah, but there can be multiple inventory. It's not only sites, it can be all kinds of stuff, right?
Yeah, exactly, right. All kinds of stuff, and you can multiplex multiple ones. And you as you say, there's kind of nice in that you can use the Kubernetes API. But honestly, it's so easy to use a gRPC client too. If you're writing a controller, right? I'll show you. Let me show you the Kubernetes.
What I see as the big change is the following, right? So we have to sort out all RBAC again. So basically, my argument is this, right? Or at least how I view the thing. We went on a track of Kubernetes and making Kubernetes the unified API system, so that you get all the benefits of that, right? Whereas here, so now you're going to build a completely new ecosystem. You have to sort out RBAC. You have to sort out policy control. You have to sort out all
Okay.
of this.
Yeah.
You are
As
building
I
a new
said,
ecosystem. Like it's like me building a new product, and every vendor does its own thing, and we are back to square zero.
You made your point, right? There are
That's
advantages to
basically
using
my high level view of what you're showing here, and I think that's for me.
Wait. Please. This is not my whole point here. But my whole point, I want to create a Kubernetes aggregator for this, but I just didn't yet. That's it. I would like there to be, I started working on this on a branch. I didn't finish it yet. But yeah, I want to create a gRPC, a Kubernetes version of this too. So yeah, that's it. That's basically, I'm basically agreeing with you that it could be nice to have a Kubernetes API version of this. I think there are certain places where gRPC has an advantage, right? If you're integrating with a northbound orchestrator or whatever, right? There are places, so it's not a problem. You can expose a RESTful one. The point is, you want it to be as well integrated as possible with the world. And you can expose different API servers for it. So yeah, I'm not disagreeing. You can absolutely do what Porch did, which is create an aggregated API. Yeah, I'm agreeing. So yeah, you can. There are instructions here how to deploy it on Kubernetes. My Kubernetes version is not completely full as the Vagrant virtual machine and installing locally, because I didn't deploy Postgres yet, so I'm using the memory backend. But yeah, a pretty straightforward deployment on Kubernetes. So again, I'm just using gRPC and HTTP here on a kind cluster. One thing that I haven't finished yet on Kubernetes, there's another component that I'm adding called a TKO runner. And the TKO runner, I can show you the Docker file for it. It kind of just installs all the Python dependencies and everything. My point here is to allow, if people want to create a plugin that's a simple Python script, one thing they can do is package it as an image and deploy it as a pod, and it will be able to run it. But the runner is a place where you can just copy files into and run them directly. So basically, the idea is that there will be a plugin type of type remote, and you can specify kind of a runner in which you want to run it. So yeah, that's how how that would be handled on Kubernetes. So yeah, I then integrated into Kubernetes entirely. It's actually kind of painful to write aggregated APIs for Kubernetes. It's non-trivial. But yeah, Wim, yeah, I think people keep taking my opinion to the extreme. I'm more about looking into pros and cons of Kubernetes as a management cluster and giving you the option, if you don't want to run it, if you already have a control plane, right, an orchestration control plane, you can integrate these into that control plane, right? If you already have some sort of general API server for all your orchestration tooling, you can add that here without forcing you necessarily to put it as a Kubernetes API, right? If gRPC is easier for you, right? So it's kind of about exposing, doing both, right? So yeah, I wonder if I jumped the gun here in showing this before I have an aggregated API. But yeah, Wim, if the only point you got from this entire presentation is that I'm trying to remove the management cluster, that is absolutely not what I intended. It's more about showing,
but
integration.
I think, yeah, so I don't know. I see. I think we have, so we started for me, this is your view of what potentially needs to happen, right? To going forward, right? So I think we have other views that we need to, let's say, analyze.
Yeah.
And based on that, we have to figure out, okay, what do we do, right? My big view here right now is that if you look to Nepio, it's basically using Kubernetes as an ecosystem. What you're basically showing right now is you're still using KRM, but all the rest is gone, right?
No, I strongly disagree with that, because Nepio right now is GitOps. Porch stores everything in Git. And
No,
I'm simply storing packages in a database instead, or also saying if you want to store them in Git, you can.
No, but see, Porch has, okay, so whether it's Git or not, that's not the point. The point is about the Kubernetes API ecosystem. That's the point. It is not about Git or
So really, when you keep going back to this, I'm not saying not to do that, right? And the same thing that Porch did.
But then, so by doing that, then we have to look at all the other components as well and the consequences of that. Yeah. So
there's some other people here. I think Fish and
I'm sorry.
waiting for a long time to get in.
I'm very sorry for that. Yeah, we're almost out of time, so I hope it's okay if people stay a bit and we can chat. I apologize.
Yeah, I think
Liam,
Fish,
go ahead, please.
Fish was before me. I don't know how. I see on your screen I'm first, but Fish, go ahead.
Yeah. So apologies, I joined late because we're internal meeting. So this proposal that you have, is it the same as a component proposal that somebody, if they want to go up and look it up to see what the motivation for this is that the document that one should be looking at?
Yeah. They're linked. I linked them on Slack, on the README, and everywhere else. You can go and see the complete proposal.
Yeah, cool. And
right,
also,
so
I think probably Wim and you probably sort of alluded to it. So that means we still are going to keep the KRM resource in your proposal?
Oh, absolutely. Yeah. If you, maybe you didn't see the whole thing. The whole thing is 100% KRM based. I think in some ways a bit even more than what we're doing with Porch right now. And I'll say too, I'm in no way saying that let's replace Nepio Core with this. This is a playground to try different things. And if there are certain aspects that are interesting to us, then we can implement them in Porch or in whatever it is we do, right? This is more about an experiment to see, all my ideas in one place, but we do not have to use all my ideas, right?
Oh, okay. So this is more experimental and alternative approach that you're thinking. Because if I were to just jump into this conversation as somebody who is going to adopt Nepio, and I have some roadmap planned, and I see some of these things changing, I'll be like, oh, wait a minute, what's happening here? So, but that's not what you're trying to do. You're actually sharing an alternate approach at this point of time.
Wish, I don't decide what the community does. I have ideas and proposals, but we all decide together, right? So I'm trying to just present my ideas. Some of them might be taken up, some might not. And, for example, maybe we'll want to consolidate on this idea of a prepare and a meta schedule, but we don't like how I handled, I say, merges in the pipeline. Maybe we want to keep the pipeline. I don't know. We have a lot of options to cherry pick some of my ideas or none of them. Maybe nothing here is interesting to anybody. And we prefer to keep things as they are, right? Yeah.
Thanks.
I'm not a decider. The fact that I'm a chair and I won your election and vote that I'm very honored to do doesn't give me any special privilege over any one of you. Wim, Vish, anybody else who would like to make a proposal about scalability, decoupling in the future is absolutely welcome to present it here. And I really do hope that nobody gives me special privileges for that. Please look at my idea from an engineering and technical and architectural level and nothing more. Okay. Liam, please.
Yeah, yeah. I guess we as a community need to examine this and also Vim's proposal and yeah, and decide. I think it's something that Vish alluded to a little bit, and just decide maybe on a process on what we're going to do and roadmap things, because we don't have too many users. We don't have too many real users of Nephio yet, but that's likely to change soon. So we also need to focus on this and how it can solve problems that we're going to have, problems that we already have, maybe on some things, but also to support what's there now and find a way of phasing stuff. I just wonder what your thoughts on that would be, Al.
So I really, it's a struggle to move forward. I suggested that, with the news about Porch, we probably want to evaluate off-the-shelf solutions and see if they can work for us with some modifications, right? If it's Flux, probably not. Argo or other systems that we can utilize, right? Maybe we'll say none of them, right? But really the core of my proposal here is decoupling, right? That was the main thing that I wanted to show, and where I started with this idea that you can have a backend interface and decouple it, which gives scalability benefits, but also gives integration benefits, right? Part of our struggle is that Nephio right now is a bit of an island, right? It has its own models. It works on a Kubernetes management cluster, right? But we don't have very strong narratives for integrating it with existing orchestration systems, right? We all tell them you have to use Nephio, right? Use our API, use our models. But we don't have stories for integrating site inventories, other template repositories, and especially doing it at scale. So decoupling is really the core of what I'm trying to show here. So it actually has two aspects. One is decoupling the backend with that interface, and the other is the plugin approach, right? That everything can be a plugin. And that plugins are very easy to write, right? And Python if you want. So it can be really just a few lines of code that just focus on the business logic that you need to do, and you don't have to worry about the entire plumbing. And you also don't have to worry about writing a cloud native operator, right? So yes, I'm all for Kubernetes, but writing operators is very hard. And if your only way for getting involved in the specialization pipeline is to write an operator, that's hard, right? So part of what we try to do with the SDK is to make that easier. And I'm showing that here too, that you can just write them in Python, right?
Yeah,
I guess any other language that uses gRPC in this case.
Yeah, I guess one question was maybe more actually towards the chair of you with your hat on as chair. How do you see us assessing and deciding how we go forward with the different proposals that's coming in?
Yeah, I think we probably need to put that in the agenda on a meeting coming close. I mean, it's not an emergency. We own the Porch code right now, and we can maintain it going forward. I've already seen some PRs going into to make fixes, and there's some plans to make it better. But and I'm fairly certain that R3 will still be based on Porch, right? The question is, what do we do next? And we might decide to maintain Porch. We might decide to keep it, maybe incorporate some of my ideas to change it a little bit. I don't know. We have the opportunity to keep that code, right? But it's an open question. I don't know what to do, right? All of my proposals here can become part of Porch, right? All of this can be somehow incorporated into Porch. I think it will have to be, the architecture will have to modify quite a bit, but it's possible, right? So, there can be a Porch 2.0 that modifies some of the architecture and does something more like what I'm proposing here, right? With kind of pluggable backends and different plugins other than just kept. right? So that's a possibility. I don't know, right? I think we're at the stage of collecting data and ideas. So I'd love very much to see Wim's proposal too, other people's ideas and thoughts, and hopefully also look at off-the-shelf things and see what they offer, how far they go, and if they can do some of the work for us, right? Because there's always an advantage of doing that, right? And not building something on our own. Yeah, so that's how I would propose moving forward. So we're really far beyond time. I apologize. I didn't see the hands up. So next meeting, we can try to kind of summarize this maybe on the agenda and kind of think how we can move forward. And Wim, if you have a presentation ready, please put it on the agenda. And I think everybody would be excited to hear more ideas.
Yeah, I'm adding myself to the agenda. But next week we have John, right? So we probably will use John. So I'm going to take the next week potentially.
Okay, great. Yeah, I don't think, again, it's not an emergency. This is not a very urgent thing that we need to replace Porch or do these things right now, but we need to start at least discussing and thinking. And that's really my point, to get people thinking about our options.
No, I agree completely. I think there's some issues with the current, with Porch, and it probably will have it's very likely to have some scalability issues, and even using Git as a backend repo and so on. But yeah, all good.
Yeah, but I think a lot also, I think Liam has to do with how we use it, right? So we have to be, but okay, let's discuss it a little bit.
No, it's thanks very much, Tal, for an excellent presentation.
Yeah, thanks.
Yeah, thank you so much, Tal. Have a good one.
Thank you, everybody. Have a good rest of the day.
Cheers. Bye-bye.